Hello everyone, and in this video we are going to discuss the question of CSES, and the name of the question is nested ranges check. And what do the problem is all about? You are going to get n set of ranges. Each of the range specifically would be having a start point and end point, right? You have to take a call corresponding to all the n ranges. You are supposed to print two outputs, right? Whether the ith range, let that be from start one till end one, right? It contains any other smaller range within that or not. Okay. So how do the smaller range would look like? It would be something like start 2 till end 2. And here what would happen is that my value of start 2 would be strictly greater than or equal to start 1. And simultaneously, my respective end 2 should be strictly lesser than or equal to end 1. These are the scenarios. Then I can straightforwardly say within start 1 and end 1, a bigger range, a smaller range is contained. So start 1 till end 1, right? This contains another range, start 2 till end. So the first line of input suggests to me, the first line of output, suggests to me that corresponding to any of the ith ranges, right? Whether it contains any other range or not. So for each and every of the ranges, you are required to print the results in terms of zeros and ones. If it is 1, then the ith range is containing any other range whose condition like this is satisfying for sure. And what do the is contained line means? Just like we have taken the scenario here, right? Start 2 till end 2. This is yet another range. And this is being enclosed by a bigger range, right? Start 1 till end 1. So I can straightforwardly say start 2 till end 2, right? That is being contained within other, correct? A smaller range is getting contained within other range since it is satisfying the criteria. Start 2 is greater than equal to start 1 and 2 is lesser than equal to n1. The smaller range is contained within a bigger range. So corresponding to this specific smaller range, right? Whatever we are taking right now, the output should be equal to that of 1 onto the second line of output. Onto the second line of output. Should that be okay? So for each and every of the I ranges whatsoever you are dealing with, right? The value of 1 here suggests that this specific range is being contained within a bigger range. And if it is 0, that means this specific range is not being fully contained within any other range at all. That's how the set of outputs look like. Correct? So let's see, by the way, that how the answers are going to be zeros and ones for the sake of your this sample input, whatever has been provided. So what are the set of ranges that has been given? It has been 1, 6, 2, 4. After that, I think it is 4, 8. And the last one is 3, 6, right? So let's take the concept. Let's take basically our first range, whatsoever it is. So it is 1, 6, right? It is 1, 6. Fine enough. So corresponding to 1, 6, what should be the output? What should be the output? I think, let me just write the ranges onto the top. And below that, I would try to write the outputs for the sake of your contains, and the next one would be is contained. So for the sake of 1, 6, does it contain any other range? Does it contain any other range? So I think corresponding to 1, 6, 2, 4, and 3, 6, both would be contained within 1, 6. Both would be completely enclosed by 1, 6, right? So output for contains would be 1. How about contained? Any bigger range you are able to observe that would completely enclose 1 and 6? I don't think so any other range resides, right? All other ranges, right? They have either their starting points greater than that of 1. And that's true. Some of them will come in terms of the contained manner within 1, 6, but none of them would be able to enclose 1, 6 fully. Should that be okay? So the answer for the is contained part would be 0. How about the next range? It's going to be 2, 4. Correct enough? 2, 4 contains any other range? I think this is the smallest range so far we have seen onto the entire set of input. Correct enough? So it does not contain any other range at all within it. Correct? The answer for this is going to be 0. Is it contained within any other range? So I can just safely say 2, 4 does get contained within 1 and 6. So the answer for the second line for 2, 4 is going to be 1. Should that be okay? Should that be okay? How about the answer for 4 to 8? How that thing is going to happen like that? So I think 4, 8, does it contain any other range? That's what firstly we are required to see. So I don't think so any other range it's going to contain. But yeah, let's try to have a look onto the input. So I can just straight away say 4, 8 is there, right? How about 3, 6? So I think this 3 falls outside of the range 4, 8, right? 3 is the starting point of this range is specifically smaller as compared to that of 4. So 3, 6 won't be contained within 4, 8. 2, 4 falls outside of the range. And after that, there is a not pure overlap with 1 and 6 as well. Correct? Correct enough? So 4 and 8 does not contain any other range for sure. So the answer for that is going to be 0. How about, is it getting contained within any other range? No. Okay, 4, 8, no specific range is completely enclosing 4, 8. Its ending point is greater. Even if I try to talk about 1, 6, right? 4, 8's ending point is greater. Rather, 4, 8 is having the greatest ending point. So there is no chance that any other range right now, as per the example, would be enclosing it fully. So the answer for that is also going to be 0. The last is coming out to be 3, 6 for us, right? Next, what will happen here? What should happen here? Who can tell? So I think 3, 6, is it containing any other range? 3, 6 contains any other range? 3, 6 contains any other range? So I don't think so. Corresponding to 3, 6, right? Either your any of the range would be having a smaller starting point or it would be having a greater ending point. So that's where specifically 3, 6 is unable to contain any other range. So answer for that is also going to be 0. How about 3, 6 getting contained within other range? So I think 1, 6 contains 3, 6 fully, right? 1, 6 is a greater range. And corresponding to that, if you try to put here 3, 6. So even if their ending points are colliding, right? 3 is value, whatever is the starting point of 3, 6, that is going greater as compared to that of 1. So 1, 6 completely contains 3, 6 for sure. So the answer for that is going to be 1. Correct enough? So let's try to match this, whatever intuitively we have solved right now, as per the sample input output. So I think the answer is 1,000 for the first line, and second line it's gonna be 0101. So we are doing it quite correctly. This is the format basically within which you are required to print the answers as a whole. Now the question comes out to be how we can try to solve that. You can try to see the constraint as well. One of the specific answers we could have tried to solve one for is that any of the ith range you are dealing with, right? Check it with all of your respective n-1 remaining ranges. If the ith range right now, once checked with the any of the remaining jth range, right? If jth range fully contains that, okay, jth range fully contains that, the ith range correspondingly. So the second line output of the ith range would be 1. If the ith range completely contains the jth range, then the first line output would be 1, right? For the ith range, whatsoever it is. Else for both of them, the answer would be 0. If any of the assumption is going wrong for both the counterparts, the result would be printed as 0. But if you are doing it for all the n ranges and corresponding to any of the range, I am required to do n-1 checking operation, right? So overall time complexity would be big O of n square. And as per the current constraint, it might not be getting accepted. So what else we can try to do? What else specifically we can try to do? Any kind of assumptions that you can try to make? So one thing I think quite we have observed is, what's that? One thing we have observed, what's that? Basically, we would require that any range from start till end, right, would contain any other range start prime to end prime, given that start prime is specifically greater than equal to start, right? And there is yet another condition, your end prime would be specifically lesser than equal to end. This condition must hold. So first thing, can I try to think greedily? Can I try to think in terms of greedy solution? How that should be, by the way? How about if I try to sort the entire set of ranges? Sort the entire set of ranges, right? In terms of increasing order of your start points. Correct? Correct enough? So if you manage to sort the entire set of ranges in terms of increasing order of start points, right? So one thing I can take for granted, what is that? If I'm standing at the ith range, right? All the upcoming ranges from I plus 1 till n-1, right? There would be significant chances that they might be getting contained within the ith range. Why? Because from I plus 1 till n-1, right? Their start prime values, whatsoever are they, would be specifically greater than the start value of the ith range for sure. That's what I can take out of guarantee. That's why I have sorted that in that specific manner. Correct enough? Correct enough. Now here there is a catch. Here there is a catch. What is it? Your start prime values, right, might even go greater than the ending point of your respective ith range. That is also possible. Start prime is greater than the start of your ith range, right? Then it might be greater than the ending point of the ith range as well. How would I just make sure that whatever may be the ending point, right, of the respective ith range, that would be specifically greater than or equal to end prime of the upcoming ranges, I plus 1 till n minus 1. How would I ensure that? That's the question that is coming. Any range works. Our question asks us that whether the current ith range contains any other range or not. So any range from I plus 1 till n minus 1, right? If its ending point specifically is ending prime, let's say, it is specifically lesser than or equal to your end of the current range, then that range would be surely contained within the ith range. Is it so? As per the starting points, it is specifically increasing. So we can take a guarantee that as per my current start, upcoming ranges whatsoever are they, their starting point would be greater than or equal to, for sure, at least equal to the current starting point. Correct. Now my task is that from I plus 1 till n minus 1, whatever it is, only the ending point that is specifically lesser than or equal to, or ending prime, let's say, whatever the convention we are following, ending prime, only those ending primes are allowed, what is specifically lesser than or equal to end of the current range. Correct. So how should I ensure at least one of them occurs from I plus 1 to n minus 1? How should I ensure that? Shall I try to keep the minimum among all? Shall I try to keep the minimum among all from I plus 1 till n minus 1, right? From I plus 1 till n minus 1. How about say that whatever is the minimum ending point that is possible? Correct. If I try to figure it out, and whatever maybe the minimum is, that is falling lesser than or equal to the end of the current ith range, then that specific minimum ending point related range would be contained within my current ith range. So the answer for ith range would be equal to that of 1 in that specific case. Else the answer would be 0. If the minimum ending point is not satisfying the criteria, any other respective ending point won't satisfy the criteria at all. Not possible. Correct enough? Correct enough. Try to give a thought onto this specific pattern. For 2 minutes, I'm pausing the video and let me know whether it makes sense or not. Okay, yes, I think you're done with the thinking, right? So just let's try to have a dry run onto my current assumption for the previous set of test case, right? Whatever we had. And that was something like your respectively 1, 6. In progress. So yes, let's have a look onto our current assumption, whatever we have made, how greedy solution is going to help us. So our respective ranges were, let's say 1, 6, post that 2, 4. After that, I think it was 4, 8. And it's going to be, I think, 3, 6 at the end, right? Okay, if you sort that in terms of increasing order of starting points, then how that's going to be helping us. So let's say it can be something like 1, 6, after that 2, 4, then 3, 6 come before, and after that 4 is 4, 8, whatever it is that goes at the end, right? So how basically we can try to take a judgment on any of the respective ith range, right? So I can just say that this is the highest starting point range whatsoever it is, right? So after that, there are no ranges at all. So contains answer for this specific range is going to be what? 0 for sure. It cannot contain any other range, right? Fine enough. And till here, right? Till here, what's the minimum ending point we are having? Till this point, what's the minimum ending point we are having? That's going to be 8. Let's keep that. And I will start moving to the just previous range. Correct enough? And I will keep on traversing onto the reverse direction. Fine enough. So what's the current starting point? It's gone of the range, whatever we are taking, 3. And its ending point is equal to that of 6. What's the so far minimum ending point we have explored? That's going to be 8, falling outside of the range 3, 6. Correct enough? So 3, 6 cannot contain any other range for sure. Even if after 3, 6, right, all other ranges are having greater than equal to start points, but the minimum ending point of any of the range is strictly outside of 6. So 3, 6 cannot contain any other range for sure. So the answer for the contains part for 3,6 is also going to be 0. And I can just say, okay, 3,6 has a smaller ending point, right? So I will update the minimum. After that, I'll move back to the just previous range, whatsoever it is. So it's going to be equal to that of 2, 4, is it so? So far, it is the smallest starting point we are exploring, right? So even after 2, 4, even if I try to take the same kind of call, that all other ranges falling after 2, 4, right? The start points are specifically greater than or equal to that of 2. But so far, what's the minimum ending point? That's 6, falling beyond 4. That's falling beyond 4, right? So 2, 4 also cannot contain any other range for sure. Is it so? So answer for the contains part of 2, 4 will also be 0. How about 1, 6? How about 1, 6? So far, this is the smallest starting point of any of the range we can try to have. Correct enough? Okay, then. So what we should try here, what's the so far minimum ending point? So once we were at 2, 4, I think the minimum of the any of the endpoints of the range should be updated to 4. 1, 6, right? 1, 6 is my current range, whatsoever it is. Whatever may be the endpoint it is having, the smallest ending point so far we have explored at all is going to be 4. Correct enough? So 1, 6 would contain the range for sure, what is ending at a 0.4. So answer for 1, 6 is going to be 1. Correct? Fine enough. So for this test case, this approach works very well, but have we missed something? Consider the case that all the respective ranges, whatsoever you are having, right? They are going to have, let's say, starting points as same. 1, 5 is there, let's say. After that, 1, 2 is there, 1, 4 is there, right? So even if you perform the sorting, all the starting points, since they are same, there might not be any sort of rearrangements possible. If your set of pairs have been arranged like this, there might not be any rearrangement at all because all the starting points are same. Correct enough? Correct enough. Now, what thing can happen is that 1, 4 should not be having any other ranges afterwards. Answer for that is going to be 0 for the contains part. After that, how about 1, 2? 1, 2. So far, the minimum ending point would be equal to that of what? So far, the minimum ending point would be equal to that of what? 4, right? Correct enough? 4. So 1, 2 should not contain any other range because its ending point is smaller as compared to that of the overall minimum of any of the ranges ending points. So answer for that is going to be 0. But ideally, we are getting something wrong. 1, 4 does contain 1, 2. So we are getting a wrong answer here, right? We are getting a wrong answer here. How we can try to rearrange then whenever the starting points are same? So we can straight away say whenever two ranges are having the same start points, right? Start 1 is equal to that of start 2, let us suppose. Then that specific scenario, try to arrange in terms of, right, the farthest ending point till the smallest ending point, right? We can just try to write that as the topmost range with all same starting points will be having the farthest endpoint, and the last range corresponding to that of all ranges having the same starting point, right, would be having the smallest endpoint. So that the at least whatever may be the first range we are dealing with, there would be a surety that that's going to be containing the endpoint, that specific range that is having the smallest endpoint for sure. Okay, what does that mean? By the way, you try to rearrange that in terms of our analogy. Whenever the ranges are having same start points, the range having the farthest endpoint would be at the top, followed by the second largest endpoint, followed by the smallest endpoint. Now start taking the call. Now start going on to the upward direction. What can happen is that 1, 2 does not contain any other range, correct? 1, 2 does not contain any other range because after that, no range resides at all as per our current example. So answer for the contains part of 1, 2 would be 0. 1, 4, what's the so far minimum ending point we have undertaken? It's going to be equal to that of 2, correct? So 4, whatever is the ending point uh, of the current range 4, right? That is greater as compared to that of 2, correct enough? So in that specific scenario, answer is going to be 1 because for 2 falls lesser than or equal to 4. After that, the minimum is still 2, whatever may be your 5, right? Whatever may be your 5 compared to that of the first range overall. That's the ending point. And as compared to that of 5, again, 2 is falling smaller. So answer for the contains part for 1, 5 should also be 1. So there are 2 points of sorting we are required to take care of. Sort in terms of increasing order of the start point. From 0th range till the n minus first range, right? Your respective start points should onto the increasing order, should be in terms of the increasing order. Now, how basically we are required to take care of the ending points, right? Corresponding to all those set of ranges, whose start points are equal. Start of I is equal to that of start of J. in that specific scenario, right? In that specific scenario, I should be able to sort in terms of decreasing order of endpoints. That's how basically I am required to sort them. That's what specifically I'm required to sort them. Should that be okay? So there are 2 points of sorting I'm required to take care of. What's that? What's that? What's that? Sort in terms of increasing order of start points, right? That's the default way. And alongside that, there is yet another condition. Those set of ranges what have same start points, they should be arranged in terms of decreasing order of their endpoints. Let's take an example, and based on that, we can try to have a dry run for the contains part at least. So that would be something like, let's say you are having 1, 5, 1, 2. After that, let's say 1, 3. Post that, you can have 2, 5, 2, 3, 2, 4. Let there be these 6 ranges. And if I sort them in terms of increasing order of start points. So let me just have some randomization. Let us suppose you are having here 1, 6 as well. Let us suppose you are having in terms of, let's say you are having the next range in terms of 2, 4. After that, yeah, let that be as it is for now. If you try to sort them in terms of your increasing order of your start points. So I think initially the sort may look like something like 1, 5, 1, 2, 1, 3. After that, 1, 6 may come up. After that, 2, 5 and 2, 4. Now again, you try to rearrange the same set of ranges whatsoever are they that are having the same start points, right? So 1, 5, 1, 2, 1, 3, 1, 6, how that can be rearranged in terms of it should be something like 1, 6 goes at the top, being the farthest ending point among all ranges that are having start point as 1. Post that, it would be 1, 5. After that, it can be 1, 3. After that, it can be 1, 2, right? And after that, these set of ranges would be getting rearranged. I think already the arrangement is intact. Farthest ending point corresponding to all those ranges that are having start point of 2, 5 is there already at the top. After that, 2, 4 comes in. Now let's apply the contains kind of answer calculation. 1, 6, 1, 5, 1, 3, 1, 2. After that, it can be 2, 5 and 2, 4, right? So far, the minimum ending point, whatever we have undertaken, it's going to be nothing. So we are just exploring the contains part for the last range. After that, no other range. It can, no other ranges at all. It cannot contain any other range for sure, right? So answer for the contains part of 2, 4 is going to be 0. After that, so far the minimum ending point is what? 4, whatever we have explored. Fine enough. So go to the above range. Are we able to see that the ending point of the current range is specifically greater as compared to that of the minimum ending point so far? Right? So that means 2, 5 contains another range and that's going to be counted as 2, 4. That's what we can try to have. So 1 is going to be there. Afterward, you move on to 1, 2. Afterwards, you move on to 1, 2, right? And I can just straight away say, what's the ending point of 1, 2? We are having 2. So far, the minimum ending point, whatever we had, right? It's going to be equal to that of 4. It's going to be equal to that of 4. So 1, 2 cannot contain any of the ranges coming after that, whose starting points are equal or greater. But even if all of them are explored, the minimum ending point among them is specifically greater than the ending point of the current range. So answer for this is going to be 0. After that, for 1, 3, right? So far, I can update right now the minimum ending point for any of the range to be 2. 1, 3 it is, right? 1, 3. 1, 3 it is. The minimum ending point so far is equal to that of 2. 1, 3 can contain that specific range ending at 2 because its starting point either would be greater or equal. So answer for that is going to be 1. After that, you move on to 1, 5. Minimum ending point is 2. So the answer for this is going to be 1. After that, again, 1, 6. Minimum ending point is 2. Answer for that is going to be 1. Correct enough? So these are the set of answers I can try to form for the contains counterpart. Now, how would you calculate the answer for the contained part? That's my question. How would you calculate the answer for contained part? Right? Is contained. Whether this specific range is contained within any other range or not. Okay, the ith range, whatsoever is the range you are dealing with, let the range be having start and end like this. Defined with the variable start and end, whether this is contained within a bigger range, start prime to end prime or not. Correct enough? Correct enough? So what if I try to have the traversal in terms of 0th index till n minus first index right now? How that's going to help us? So if I am at the ith range, right? If I am at the ith range, I am sure that all the respective ranges from 0 till I minus 1, their start points would be lesser than or equal to the start point of the ith range. Let me name that as start prime. Correct? Their start prime would be either equal to that of start of the ith range, or it would be further lesser, or it would be further lesser. Correct enough? All we require is that if the ith range is to be contained within any other range, the ending point of that specific range, let that be end prime. End prime should be strictly greater than or equal to end of the ith range. So I can try to keep a maximum factor for that. Any of the previous ranges whose start points falls either equal or smaller, what's the so far maximum ending point I have at all got? So if that maximum ending point, the farthest range at all possible, right, it is greater than or equal to that of ending point of my current range, for sure that bigger range would be containing my current ith range. So ith range is contained within that. So ith range is contained within that, right? Let's try to see how does that work. So I am right now onto the 0th index. So it is not contained within any other range for sure because it is the farthest range. Nobody can contain that. So overall, I can straight away say the answer for the is contained counterpart for 1, 6 is going to be 0. And so far, what's the maximum ending point corresponding to any of the ranges that is possible? What's that? That's going to be 6. Correct? That's going to be 6. Go to the case of 1, 5. Go to the case of 1, 5. So I think right now 1, 5. What's the ending point of that? 5. Does it fall lesser than or equal to the maximum ending point of any of the range so far? Yes. So the is contained counterpart would be 1 for 1, 5. How about 1, 3? Compare that with the maximum ending point so far. 6, 3 falls within that 6, right? So the answer for that would be 1, 3. After that, I can say 1. The answer for 1, 2, what that will be? Maximum ending point for any of the range so far is 6. So answer for this also would be 1. How about 2, 5, ending point 5, compare with 6. 5 is lesser than equal to true. Answer for that would be 1. 2, 4, maximum ending point comparison. 4 is smaller than or equal to 6. So answer for this also is going to be 1. So any of these ranges can be contained within 1, 6. Correct enough? Let's take another example, right? So that any more randomization we can try to assume, and let that be a smaller set of example. Let that be you are having 1, 5. After that, let there be 2, 7. Okay. 1, 5, 2, 7, 3, 9, 1, 4, 3, 6. Let this be the set of ranges, whatever we are having. Now, first task is sort them in terms of increasing order of your starting points, right? So how they are going to be looking like? I think 1, 5 goes at the top, and after that 1, 4. Okay, let's try to write directly rather than sorting, having the assumptions of sorting twice, whatever we have done here. So 1, 5, 1, 4 would be coming at the top. And after that, I think 2, 7 comes into the picture. Then 3, 9, then 3, 6. Anyhow, that's going to be the scenario. Now you are going to calculate the answer for contains and is contained, right enough? Okay, so for the part of contains, let's try to traverse from n minus first range till the 0th range after the sorting, howsoever it looks like. So the contains answer for 3, 6. After that, no other range. It cannot contain anything else. So its answer is going to be 0. How about 3, 6? How about 3, 9? So far, the minimum ending point for any of the range, what that gonna be? What's that gonna be, by the way? 6. So the ending point of the previous range 9, right? That is specifically greater than or equal to 6. 3, 9 contains the 3, 6 range for sure. So answer for that would be 1. After that, 2, 7. After that, 2, 7. Definitely, whatever is the minimum ending point we are having corresponding to any of the range, that's going to be 6 so far. 7 is greater than that. So 2, 7 can contain that minimum ending point range, right? So the answer for that would be 1. How about 1, 4? How about 1, 4? Its ending point is smaller as compared to that of 6. It cannot contain even the minimum ending point range, whatever is upcoming, right? Okay, what can lie ahead of that? So answer for that would be 0, and I can update the minimum ending point as 4. 1, 5, what is the ending point here? It's going to be equal to that of 5, greater than 4. So the answer for 1, 5 in terms of the contains counterpart would be what? Would be equal to that of 1, right? Okay, done. Next, what will happen? Do the traversal from 0th index till n minus first index, right? Till n minus first index for the is contained counterpart. For the is contained counterpart, and how that's going to be looking like. Let's try to see that. Fine enough. So we are required to keep the maximum measure here. Any of the ranges, whatsoever it is, what is it so far maximum ending point? Correct enough? Correct enough. So far, it is nothing. For the first range, I can say, right, that it is not being contained within any other range for sure, because prior to that, there is no other range. So the answer for the is contained counterpart of 1, 5 would be 0. After that, I think I can try to assign maximum ending point corresponding to any other range would be 5. How about 1, 4? 1, 4 can contain one, sorry, 1, 4 is contained within any other range or not. That's what you are required to see, right? This is all about is contained. So 1, 5 cannot be contained actually within any other range because no range prior to that. So the answer for that would be 0. Correct enough? Fine. Okay, fine. How about 1, 4? How about 1, 4? 1, 4 can be contained within any other range? I think yes, because there is a maximum ending point of 5 prior to that. 1, 5 can contain 1, 4. So 1, 4 is contained within 1, 5. So answer is for that is going to be 1. How about next? How about next 2, 7? What will happen here? What will happen here? Whatever is the ending point here, right? Among all those ranges prior to this, the maximum ending point is smaller to that. So 2, 7 can't be contained even within that max ending point range, whatsoever is there as per the indication. So answer for that would be 0, and max ending point range, whatsoever it is, we can have would be equal to that of 7. Would be equal to that of 7. That's what I'm going to update. After that, 3, 9. 9 is greater than 7. So it cannot be contained even within the max ending point range. So answer for that would be 0 again. How about 3, 6? Answer, and the max ending point would be updated to 9. How about 3, 6? Ending point of 3, 6 is specifically what? Smaller as compared to that of 9. So 3, 6 can be contained within 3, 9. Correct? So I can just straight away say the answer for that would be 1. 6, compare that with 9. The ending point is greater as compared to that of 6. It can be contained within that higher ending point range, whatsoever it is. So the corresponding counterpart of your is contained would be 0, 1, 0, 0, 1. So it is all about performing some custom sorting, right? That's how we can try to solve this question, and we can do that greedily. If I try to just rely upon the sorting counterpart within big O of n log n, max I would be able to solve the question. Okay, that's going to be the time complexity. Rest 2n iterations are going to be taking place, but n log n factor would be greater. So overall complexity would be m log n. That's the governing one for us. So that's how we can try to assume the solving of this question. If you like the video, please like, share, and subscribe. In the next part of that, I'll show all of you how to code up the problem. Thank you all.